In this video, I'd like you to evaluate the inverse cosine of, say, negative 1 over the square root of 2. So remember that the inverse cosine has another name for it. That would be the tangent arc cosine. And it's just another way of writing an inverse function is to use the word arc. So on your calculator, you'd be using this notation, but oftentimes in a math class or textbook, we use the arc cosine notation rather than inverse cosine. Remind yourself all along that these are just names of the function. It's back in algebra where they taught you function notation, where you give a name of the function here, f, and this is simply its input, and your job is to evaluate the function at that input and find its corresponding output. So that's exactly what's going on here. We're just giving it two different names. This is this is the name, like f in function notation. There's nothing being raised to the negative 1 power here. That never stops confusing students, but remember that the little minus 1 is just part of the name. There's nothing being raised to the negative 1 power, and that's why some teachers like myself like the arc cosine notation rather than this, because this has less chance of confusing students that there somehow is something being raised to the negative 1 power. This is just the name of the function. This is just the name of the function. Nothing being raised to the negative 1 power. So that being said, let me erase this all and talk about how you'd evaluate the inverse cosine of negative 1 over rad 2. So let me point out, first of all, that evaluating the inverse cosine at this ratio of sides is exactly the same as saying solve this equation for x. In fact, a lot of times what I do is I'll say that the inverse cosine is the angle whose cosine comes out to be this. So another way of saying that is find x, find the angle whose cosine of that angle would come out to be negative 1 over the square root of 2. And I always like to try to do at least a little bit by hand at first. So I know that I'm looking for an angle so that the adjacent over the hypotenuse, that's the definition of cosine, comes out in this way. So one thing that you have to know about finding the inverse cosine on your calculator is when we do this, because there's infinitely many answers, right? There's infinitely many angles for which the cosine comes out this way, we have to all agree on which answer to give. So whenever one evaluates the inverse cosine, it comes out a little different than sine or inverse sine and inverse tangent. For inverse sine and inverse tangent, whenever you do that on your calculator, you always get answers in quadrant 1 or quadrant 4. Inverse cosine is a little unique. Inverse cosine, when you take the inverse cosine, you are to always report your answers either in quadrant 1 or quadrant 2, and that's just something that you need to remember. So in a minute, when I take the inverse cosine of negative 1 over radical 2 on my calculator, I guarantee the answer is going to be either in quadrant 1 or quadrant 2. But I can actually predict which, because the ratio of sides is negative here, I can even tell you which one. So if you remember the acronym all students take calculus, the A in all means that all three trig functions, sine, cosine, and tangent, are positive here. Well, I don't want the cosine to come out to be positive. I want the cosine to come out to be negative. So this would not be the quadrant for which we are to respond or answer our angle in. So if I was to take the inverse cosine on my calculator, it's going to give me always an answer in quadrant 1 or 2. If my input to the inverse cosine is negative, if you provide a ratio of sides that's negative, it has to be quadrant 2, right? Cosine's positive in quadrant 1. That doesn't work. So if you remember the S in all students take calculus, that's just a fast way to remember that in quadrant 2, it's the sine function's positive, meaning the other two are negative, meaning cosine's going to come out negative and tangent's going to come out to be negative. So that's exactly what I want. I want the angle so that the cosine comes out to be negative. So when I take the inverse cosine on my calculator, in general it gives me an answer either in quadrant 1 or 2. But because I'm providing in a negative ratio here, it definitely has to give me an answer in quadrant 2. So I like to do as much as I can by hand though. So I want to figure out what my calculator is going to give me. So the adjacent over hypotenuse has to come out to be negative 1 over rad 2. So looking at my reference angle here, the real angle, mind you, is from here to there, to this terminal side. But we're going to use this reference angle to help. Now the adjacent side needs to be labeled negative 1, and the hypotenuse needs to be labeled square root of 2. And things don't always come out this nice. We just usually pick these kinds of numbers to develop intuition and have you memorize a few basic things so that we can do some things by hand. So if you did the Pythagorean theorem, you'd find out that this side is 1. To get these sides to obey the Pythagorean theorem, this needs to be 1. And by the way, the reason I labeled this -1 and this +1 is if you were to label this point in quadrant 2, you would have to label the x value negative and the y value positive. So if you remember your special triangles, the only way this works out is if this is 45 degrees. So that's the reference angle, 45 degrees, but that's not the actual angle. When you do the inverse cosine, that is just the angle that helps me find the answer, hence the name reference angle. The real angle is starting on the positive side of the x-axis, rotating clockwise until you get to that terminal side. So if the reference angle here is 45, what would this angle here be? So if you remember right, you have to go 180 degrees to get all the way to the negative side of the x-axis. Think of that as going too far. Going 180 would be this far. I'd have to subtract off my reference angle of 45 degrees to get to right here. So 180 minus 45, let me see. 180 minus 40 would be 140. If I subtract 5 more, that would be 135. I don't have a calculator handy, so I'm guessing that in a second when I take inverse cosine of -1 over square root of 2 on my calculator, it's going to give me the angle 135 degrees. So if you give the calculator inverse cosine of a negative ratio, it's always going to be in quadrant 2. Positive ratio, it'll give you an angle in quadrant 1. And angles in quadrant 2 are always between 90 and 90 and 180. So I was thinking that the calculator is going to give me an answer between 90 and 180 degrees. Again, if I was to do the inverse cosine of a positive angle, it would give me the answer in quadrant 1, which is between 0 and 90 degrees. So just to give you an idea what to expect on your calculator. So finally, let me go back, let me clear all this. Let's go to the calculator and do the inverse cosine of -1 over the square root of 2. And as promised, I'm going to get an answer between 90 degrees and 180. Why? I'm doing the inverse cosine. Inverse cosine always reports answers either in quadrant 1 or quadrant 2, which is 0 to 180. But since I'm providing a negative ratio of sides, it's going to be between 90 and 180, and indeed it's 135. So this is sort of what I think of you get for free with the calculator. You get one of the answers for free. The question is, would you be able to produce the other answers? So suppose that's all I did. Let's back up and suppose that I didn't do anything yet except for take the inverse cosine on my calculator and get that the answer is 135. With that, could I go backwards and find the reference angle? So the idea is I would know that 135 degrees is bigger than 90 but less than 180. So I could kind of work backwards and find that reference angle by not doing all of this, what I did. That's great review. But another way was to say, well, the calculator's telling me that the inverse cosine comes out to be 135, meaning 135 degrees is one of the angles, so that the cosine of that angle comes out to have this number. So I would have to work backwards and find the reference angle if I had any chance at all of finding more answers. Remember, there's infinitely many angles that work. To find more answers besides the 135, it always relies on finding that reference angle. So suppose I didn't do any of this labeling here, because in real life you don't actually get nice, numbers like square root of 2, square root of 3. You just get some decimal answers and you have to do it another way. So what you'd have to do is say, well, to find the reference angle in here, since 180 degrees is all the way from the positive side of the x-axis to the negative side, and I don't want to go that far. Going 180 is too far. This much is 135. If I want just this angle in between, what I could do is I could take 180 degrees, which is all the way from here to there. I could subtract off the 135, and that would give me the reference angle in here. So if you did that, you'd get your 45 degrees, and you could use that to find any other angle that you wanted, in some region. So for example, let me kind of clear this up. Now that I know my reference angle, what I could do is start with a clean slate and say, well, how could I find other angles so that the cosine comes out that way. So one of the angles was 135 degrees. That led me to find the reference angle to be 45. I want to find more angles that work. So without using a calculator, how could I find more angles? Well, again, you have to look back at all students take calculus, and this is just one place where the cosine comes out negative. There's always two places between 0 and 360 degrees, one time around the circle. There's always two places where cosine is positive, and always two places where cosine is negative. So where are the places where cosine is positive? Well, that's here, where all of them are positive, and here, where cosine is positive. Meaning, here's the two quadrants where cosine is positive. That means quadrant 2 and quadrant 3 are the quadrants where cosine is negative. So my other answer between 0 and 360 degrees would be in quadrant 3. I don't know why I'm drawing this at an angle, but in quadrant 3, if I drew a reference angle with 45 degrees, how would I find that angle? Well, that angle, remember we always start with the positive side of our x-axis. One way of representing this angle I'm drawing here would be to go 180 degrees, that's this far, and add 45 more. So 180 degrees plus 45 would be the other answer between 0 and 360, the other angle for which the cosine comes out to have this ratio here. So what is that? That's 225 degrees, is it? So let me go check and see if that is correct on my calculator. If I take, let's clear this, the cosine of 225 degrees, that should give me the same answer as if I did the cosine of, what was our other answer? 135 was our other answer. So the first answer we found on the calculator was 135 degrees. So remember, that's the other answer. Cosine 135 was the other answer. So, and maybe you're not a human calculator. Maybe you don't see that this is the decimal equivalent to negative 1 over the square root of 2. So just to show you, negative 1 over the square root of 2 is indeed this decimal. So here are two angles between 0 and 360 for which you get negative 1 over rad 2. If you wanted to find more, you could just keep repeating this process. You could go once around the circle, which is 360, add 135, or you could go once around the circle 360 and add 225. Other ways is you could go clockwise and represent this angle in a negative way. So to bridge these concepts with the graphing calculator, remember in previous courses you could solve an equation by simply typing one side of the equation, that would be this right here, into y1, and type this into y2 and find out where they intersect. So if I do that, I should be able to reproduce these answers of 135 and 225. So I'm going to go to my calculator, I'm going to hit y equals. I actually did this example and messed up the video, so everything's already done for me. Cosine x is in y1, negative 1 over radical 2 is in y2. You do have to set your window up to make sense of it. So since I found answers once around the circle from 0 to 360, if you go to window, set your x-min and your x-max so that you're going from 0 to 360 degrees. That's once around the circle in a counterclockwise fashion. So setting that from 0 to 360 is good. Then what should my outputs be? If you remember from a previous part of the course, the cosine function, when you graph it, that's this guy, y equals cosine x, from 0 to 360 degrees, that's one cycle of the cosine function. You were to sort of just memorize the graph and know that since the amplitude is 1 here, it would go as low as negative 1 and as high as positive 1. So knowing that, I put my y-min at negative 1 and my y-max at positive 1. And we want to know when the outputs of cosine are going to be as low as negative 1 over square root of 2. So that's that negative 0.7. So when I graph y equals negative 0.707 here, it should be a horizontal line through negative 0.707, and I should get these two intersections here that represent the 135 and 225. So a lot to learn in one video. Let me graph this, and indeed I get the cosine function going as low as negative 1, as high as positive 1. I'm graphing it from 0 to 360, which is one full cycle of the cosine function. You probably remember that is 2 pi units because we typically dealt in radians. I want to use my intersect feature to find these intersections now to solve this using my graphing calculator. So I'm going to hit second trace to access the calc menu, number 5 for intersect, and the first two questions I always just press enter. Is this the first curve? Yes, enter. Is this the second curve? Yes, enter. The first intersection is free. You can just press enter and not think about it. And it says one of the intersections is 135 degrees. And here's my y value. You see the decimal equivalent to negative 1 over square root of 2, meaning this is one angle for which the cosine comes out to be negative 0.7. If you want another angle, you could repeat the process. Second calc, number 5. Is this the first equation? Yes, enter. Is this the second equation? Yes, enter. But don't press enter right now on the guess. If you press enter here, it's going to give you the same information back at 135 degrees. So you need a right arrow over and make sure that your guess is closer to the rightmost intersection because we haven't found that one yet. I'm going to go a little too far just to be safe. I'm going to guess that the answer is 237, which is wrong, but it's just a guess. And I'm going to press enter, let it think about it, and wait for the intersection. It says that the other intersection between 0 and 360 is 225. So as you see, the calculator basically gives me all the answers I need. It's just that the human needs to understand the connections between the answers the calculator gives and the definition. What is the definition of cosine? How is the calculator getting these x and y values is all based on these definitions of reference angles and reference triangles. So perhaps what I need to do now is get out of our comfort zone where all our answers come out to be 30, 60, 45. I should give you a question where the answer comes out ugly, and we sort of lose a little bit of intuition, but the overall concepts will remain, and you can still get through the problem. So a lot to learn in one video. I hope it helped.